of all, my screen is visible, right?
Excellent.
Yes, it's visible.
Yeah, good. So, okay, so we'll start with the introduction. So, what is awk? So, awk is basically a tool which is used to scan or read files and then print out some part of the data, or sometimes you can print all of the data which are available in that particular file. So, it's basically a data reading tool. Now the second line, awk scans data into the buffer. Okay. And what are the types of these buffers? So there are two types of these buffers. One is fields and other is records. So first, I'll first explain what are these two, and then we'll dive into deep for both of them. So those terms might sound a little bit tricky, but I'll write the easier terminologies for them. So majority of us here are aware that what is a table, right? Uh, we can like insert table from here, and I will show you what. Yeah, all of us know what a table means. So basically, table has two major characteristics, right? One is row and other is column. We know that row is the horizontal one and column is a vertical one, right? So, what is row here and what is column? So, records here stands for the rows in your table basically, and fields are nothing but columns in your table. Now, it's kind of very understandable that let's say you have some sentence. This is a sentence. Then this whole sentence is a row, right? It is a horizontal row. So it is called a record in your row. Let's say this is inside a file, then this is a sentence. This is called a record. And what is the field? Each word of this sentence is a field. So this is a field, is a field, a is field, and sentence is field. So these four are basically fields of your records. If I write another sentence here, this is another sentence, then this is your second record in your file. This is your first record. This is your second record. This is your first field, second field, third field, and fourth field. So each record here is having four fields. So yeah, that's the basic understanding of what is a field and what is a record here. We'll now go into the deep of each. Okay, so first we'll cover what is fields and like what all are there for fields. So to access the nth field, we write dollar and then n in the awk. Okay, and also we should note that fields here follow one based indexing, which means that this is your first field, which is represented by $1. This is second field represented by $2. This is $3, and this here sentence is $4. So unlike your programming language arrays, which are generally zero based, our fields here are one based indexing. Okay, and now we'll understand these three terms related to your fields. So first term here, which is NF, which stands for number of fields in your current record. So whenever your awk is reading data buffer by buffer, so it will first read this as a field, then this word, and this sentence word. Okay, so currently it had like read four fields. Okay, four fields, and then somehow he knows that this record is over here. Okay, this record is over. Then it will set nf to 4, like that. So basically, whenever your awk encounters that your particular record is over here, it will, like, at that particular moment, NF will be 4, which is like number of fields in that particular record. All right. So if your sentence is having, let's say, some extra word here, then your NF will be 5 here. So it's very simple. NF stands for number of fields. Now, um, when I said that somehow your awk knows that your record is over here. So how does your awk knows that when your field is getting over, or when your record is getting over? So there should be some terminologies, right? Like how does awk knows that your sentence, where your record is getting over and where your field is getting over? So for that, there are terminologies. First one is FS, which stands for field separator. Okay, so yeah, so what this FS means is, uh, it tells you that uh, it tells awk that where your field is getting ended. So which means that like default FS, which is like default field separator, if you don't provide any field separator, then by default it will be set to uh, empty space, which is a white space. So by default, your field separator is white space, which means that whenever your awk encounters a white space, now awk concludes that this is end of your field. So let's say I take another example where I have some names. Let's say John, and I have 30, and I have Bob, 50. Okay. So it will read this John, and then it encounters white space. So now he knows that your field is over here. Then it reads 30. Okay. And it reads a new line, which is /n operator. We know that it encounters as a new line. Then he knows that it is a end of your record. So that's a record separator. We'll cover that here. But what is a field separator again? Like it tells when to separate field, and record separator tells you when to end your record. Okay. So by default value of record separator will be /n. So whenever your awk encounters new line, it it will know that it is a new line, it's a new record, and whenever it encounters space, it will know that it is a new field. Now sometimes your input file might not just contain spaces, it might contain some special symbols also. Let's say it is showing like this: John equal to 30, Bob equal to 40, and Ted equal to 50. Let's say this is your input file. Now what you want is you want your awk to consider this John and 30 both as separate fields. So at that time you will give fs equal to. So now your awk will consider both of them as different fields. Yeah, it's too much theory. Now we'll just go to terminal once and check how all of these things work. Okay, so we have a file here named hello.txt, which consists of 5 records, you can see, and 3 fields each. So first I will write just basic command. So first I will tell you syntax of awk. So it goes like this: awk. Then you will write single inverted comma and curly brackets and single inverted comma over. So this is your action part. Whatever you write inside the curly braces, that's your action part. Whatever action you want to perform, on your file. Which file? That you will write after the single inverted comma. So here we want to perform action on this hello.txt. So we will write file name here, hello.txt. So basically there are these three parts. First is awk, then action part, and then file name, whatever you want to perform action on. So initially we'll just write print and see what it prints. So yeah, you can see that it prints the whole file which was written here basically. So yeah, that's about that. Now let's say we just want to print first fields from each record. We just want to print first record. So we'll write print $1 here and press enter. Then you can see that it just prints the first records. Let's say we just want to print the salaries, which is the third record. So we'll write $3. You can see that it just prints the $3 here. Okay. Now let's see something interesting there, which was mentioned there, which is OFS. What is this OFS? OFS stands for Output Field Separator. Field separator means whenever you are printing something, some records, then they are by default separated by space. You can see here that they are separated by spaces. So instead of space, if you want to have some other symbol, let's say plus symbol, so how do we do that? So what we'll do is we'll do awk and we'll write what is this begin? Then I will cover later. Don't worry about it now. OFS equal to plus, and then we'll print $1, comma $3, and then we'll write hello.txt. Yeah, now you can see that we got first and third records from each record of first and third field from each record separated by a plus sign. If instead of plus we want double equal to, let's see, so we'll just write double equal to here, and when we press enter we can see that we got these two fields separated by double equal to. So basically it tells you what symbol do you want between your fields in your output. Yeah, that's about it. Now let's take example for fs. So here you can see this file fs.txt where I have written a dash instead of spaces. So first I will execute it normally and see what it prints actually. Let's say I want to print $1 and fs.txt. Yeah, I forgot curly braces. Yeah, so you can see that I just wrote $1, though it printed whole sentence, like whole record, because I didn't specify here the field separator. So I need to specify the field separator fs equal to hyphen. And now if I press enter, you can see that it just prints this. If I want to print another other fields also, then I will add $1, $2, $3, and you can see that it will print 3. Now if I want uh, them to be separated by something like, let's say, percentage, then I will just write this here, and you can see that now all of them are separated by a percentage sign because I've specified output field separator as percentage. So yeah, that's about field separator and output field separator here. And that's pretty much about all for fields. Now I will tell about records quickly. So yeah, to access nth record, you can't write something like $n because that's already for fields. One thing I forgot to mention there was if you write $0, if you're at $0, then $0 represents current record. Okay, $0 represents current record. So if I write here $0, then it will print like all records. So yeah, that's something you should know. The $0 represents current record. Now what is NR? NR stand, it's like counter variable, which will be having current records counter. Okay, so if you are at first record, then your NR value will be 1. If you are at second record, your NR value will be 2, like that. Now, coming to this, let's say if we want to just print this line. So you can see that it's a fourth line, right? So if you just want to print fourth line, then what you will write is NR double equal to 4, and then print $0, which means whole line, and for the file hello.txt. So you can see that it just printed this particular line here. If you want to print just the third line, then you will write NR double equal to 3, and you can see that it just prints this particular line. So basically this NR stands for your counter of records, basically. So now what is RS that we already covered, that it is a record separator, which is by, if you don't mention anything, then by default its value will be /n, which is like a new line. So let's try to understand record separator a little bit. So what I'm going to do is I will write these 3 sentences in one line and separated by semicolons. Now if I first call it normally, let's say I write print $0 fs.txt. Let's see what happens. Okay, I forgot curly braces again. Yeah, you can see that it prints whole sentence as one. Okay, it considers this whole 3 sentences as one record. But what we want is we want to consider it separately. So what we are going to do is we'll just provide rs equal to semicolon, and let's see what happens. Yeah, now you can see that it prints them separately, and semicolon is not printed also because it's a separator. So separator is always ignored while printing. Okay, it basically it separates this and this, so you don't need to print it. And also we can write here along with this rs, we can write fs also as hyphen and ofs as modulo. And here we can just write print $1, $2, $3, $4. And if we execute this, you can see that hyphen is now replaced with modulo. And also we will see what is ORS, which is output record separator. Okay, which is by default a new sentence. You can see that each record is printed on just new line. Instead of single new line, let's say you want to print each record on double new line, like you want extra line between these records, then what you will do is ORS equal to /n 2 times. And now if you just click enter, you can see that there are extra lines between these records. So yeah, that's pretty much all about records, fields, and every terminologies that you should know about records and fields. So till now, if you have any doubts, please type in the chat box, or if everything is clear, then just type yes at least in the chat box so that I will be happy. Maybe one, yeah, thanks. That's great. Okay, so yeah, we'll move forward. Okay, so what is pattern matching? So if it just scans and prints the data, then there was no point, right? That's something that very easy task to do. So awk also provides a pattern matching in your, like, while you are scanning the database, you will only print those data which is like matching with your pattern. Let's say in our hello.txt file, if you want only those data, like only those rows which contains manager. All right, so what you will write is, before your action you will write the pattern. This is, I told you, right, the curly braces is your action part. So I'm printing $0, which is, I'll print whole record from hello.txt. But this time I only want to print those line which contains manager. So this line here is your regular expression pattern matching, which is called regex. So I hope majority of you will know what is regular expression. If you don't know, just Google about it. Um, yeah, it's kind of very basic thing. We will not cover it here, but it actually is used for pattern matching. So if I write manager here and print enter, you can see that it will just print those records which have manager word inside them. All right. Let's try something else. Let's say I want only those names which contain A followed by either C or D. Okay, what I told? I want only those names which have A followed by C and D. So you can see that it's this name, Rachit and Aditya. Those two have A followed by C or D. So how will we write that? Let's see. So this particular part is same, but here, first of all, we want to compare name. So we can see that name is in first field, right? Name is our first field. So we'll write $1. $1 stands for first field. Then we'll write this symbol, which is used for regex. Uh, and these two slashes are also used for regex. And inside these two slashes, you will write whatever pattern you want. So first I want A, then I want either C or D. So if you, when you want to write either or situation in regex, you will use this box bracket. Now, whatever you write inside the box bracket, those are considered as equal. So like A followed by C or D. So yeah, let's see what it prints. So you can see that it prints two records, AC and AD. So yeah, that's uh, it. And let's say if we want to print those names which have A at the end. So that will be Aditya and Dikshita, right? So we'll make some changes here. What we are going to do is we will remove these and we will use $sign. So if you know regular expressions, you know that dollar is used for ending, like only those words which are ending with something. Whatever you have written before dollar, that will be your ending pattern matching. And if you want names starting with it, then you will use cap. So cap is used for starting and dollar is used for ending. That's something you should know if you know regular expressions. So if I press enter, you can see that we got Aditya and Dikshita records. So yeah, that's pretty much all about pattern matching. Also, I would like to say that, like, the major purpose is also kind of similar to if condition. Like, it's not just about regular expression. You can write conditions also. Let's say I want all records where your salary is greater than 40,000. So salary, we know that it's third field, right? So we'll write $3 is greater than 40,000. So if I print enter, you can see that we got only three salaries which were greater than 40,000. And if you recall, in the start of the session, I wrote NR double equal to 3, NR double equal to 4. So that was also kind of a condition only, like where your NR is getting 4. So that's a condition. So that condition you can write here. Now also something about NR, that if you write NR 2, comma, NR double equal to 4, then what it will do is it will print all the records starting from 2, ending with 4. So 2 to 4, 2, 3, 4, all are printed. But instead, if you just want second and fourth, not the like the between ones, then instead of comma, you will use semicolon here. So if you enter now, then you can see that it just printed second and fourth, not the in between ones. So yeah, that's all about pattern matching, regular expression, if condition, everything. You can also compare these particular words. Let's say if you want Rachit only, then you can write just $1 double equal to Rachit also. That's up to you. Whatever you want, you can play with pattern matching. It's a really vast topic. Regex in itself is a very vast topic. So yeah, we already jumped into terminal. Now coming to the begin and end. So I have already used them in between the begin one. So when they are used, so begin is used when whatever you have written inside your begin block, that will be executed before everything, like whatever you write, whatever actions, like you can actually write so many actions inside your single inverted comma, but that action will be performed first, which have written begin, and others will be performed later, like in the order, whatever order is there. So why do we need begin? So the major usage are for declaring these four variables, which are field separator, record separator, output field separator, and output record separator. Because you want to declare those before scanning or printing, right? Because like field separator, you need to specify before you start scanning. Otherwise, how will your awk know that what is field separator? You have to give it in beginning itself. Also, record separator you need to give in beginning itself. So yeah, those are things that you need to give in beginning. That's why you use begin there. Also, whenever you are like performing some big programs where you need variables and arrays, and also at that time, if you want to initialize any variable, then that you can do in begin part. Now, where you use end, so end is used when you want to perform that action at the end. Okay, so if I write end, then this action inside this curly bracket will be executed at the end of your complete scanning. Okay, so when it is used, so major it is used to print NR, because if you print NR at the end, then it will stand for total number of records in your document, right? Because you are printing it after scanning is complete. So after scanning is complete, your NR will be pointing to the last record. So if I do just here, you can see that it will print 5 because there are 5 records. So if you write, let's say if I write something else here also, let's say I write print $0, and then I write this. So yeah, it even if I write and before and print 0 later, it won't execute this first because I have written it inside end. So see, you can see that end is written like this is written before this part, though it is executed later because of end block. So yeah, that's pretty much about end. And as I told before, that if it's a big program where you are performing some actions using variables and array and all. Let's say you are performing a task that you are given an array of numbers and you want sum of all of them. So what you will do is you will initialize a variable in your begin. Let's say sum equal to 0, and then you will run a for loop in a normal action block, and in your end block you will print your sum value, because like you want to print sum after you are done with scanning your whole uh, array, right? So yeah, that's about begin and end. Uh, Now coming to built-in functions, there are a lot of big built-in functions in your awk, which are, I'll just quickly go through it and show you one or two of them. So first, there are numeric functions. Int n. This what it does is it gives you floor. Okay, floor function. Like if you write three int of 3.5, then it will give you 3. Okay, the integer part basically. Log we already know. Square root we already know. Sine we know. Cos we know. So these are some basic functions that we all of us knows. And yeah, now about string. So this is something interesting. Index, parent, and pattern. So what it does is it searches for the pattern inside the parent string and returns the first occurring index. Let's say I will just show you example here only. So if I write awk and print, what I'm gonna print is index of hello is your parent, and let's say you want to search for double L inside your hello. Yeah. Let's see what it prints. Yeah, I need to write it in begin, otherwise it won't execute. Yeah, you can see that it prints 3. So why it is printing 3? Because it returns the first occurring position. So you can see that first L occurs at third position. So it prints 3. If I write ELL, then it will print 2. Yeah, you can see that it prints 2. So that's about the index. Now what is length? So it returns the length of your string. Let's say I write length of hello, and you can see that it returns 5. Now what is substr? So it returns substring of your string. Let's say I want substr of hello string starting from second position up to like this is the second parameter will be your starting position, and third parameter will be length of your resulting substring. So here I want only 2 letters starting from E, so it will print EL. Yeah, I forgot C bracket. Yeah, you can see that it prints EL, which is like starting from second and up to 2. Okay. So that's about substr, and these are 2 lower and 2 upper. 2 lower prints your whole string in lower letters. 2 upper prints it in upper letters, all of the upper letters. So yeah, that's all about. I can show you one numeric example also. Let's say if I write uh, print sqrt of 49, let's say. Yeah, you can see that it prints 7. So yeah, you can use this function with your fields also. Like you can do square root of your salary or something, whatever you want. Okay, so that's about built-in functions. Now coming to the arrays. Uh, so there are like unlike your C++, in your C++, your arrays are basically continuous indexing of numbers 0, 1, 2, 3 up to n. But here index can be number or string. So it's not more of an array, but it's more of a map uh, where you like the index can be anything, number as well as string. Also, your indices need not be sorted here, and it can be random. Also, your size need not be specified. Your array can be of any random size, like it's a dynamic array. Okay, so let's see how your array works basically. So if that's your awk script, let's see, and we have like, let's say fruits is our array, and let's say apple, and we have like 20, let's say, and also we have fruits of, let's say, orange, and we have 10 equal to 10. Yeah. And let's say we want to print now apple. So what we will write is print fruits of apple. Yeah. And we'll write this inside begin. Yeah, you can see that it prints 20, which was standing for fruits of apple. And let's say if you want to delete some record, then instead of print, you will just write delete. Then if you want to print your whole array, then you can do it using for loop for I in fruits print I. You can see that it just printed orange. And if you want to print orange as well as the value of orange, then you can print fruits of I as well. And you can see that it prints orange, like space 10. Okay. And because we deleted apple, if we don't delete apple there, and again do this, then it will print apple as well. So yeah, that's about array. It's pretty much very simple and common as all programming languages. And yeah, the last part, which is the other tools. So in other tools, those are like your normal tools, which are not like pretty common in programming languages, which is condition. So conditions are basically if else and else if conditions. Loops. So as per all languages, there are three kind of loops: for loop and while loop and do while loop. So for for loop, I shown you example here also. Let's say I show another example where we want to print 1 to 10. So what we are going to do is we'll write for I equal to 1, I is less than or equal to 10, I plus plus, print I, and yeah, you can see that it prints 1 to 10. So it's pretty common. You can use while and do while loop also. There are same only. Okay, so also there are user-defined functions like programming languages where you can like write parameters function and return some stuff. What are like if you want to perform sum of two numbers, like add two numbers, then you can write like this: add A, B, and then you can perform some actions on them, and then you can return A plus B. Like that it works, like return statement, which is very normal. So you can just explore this stuff, which is like not very common. Like functions are not very much useful, but loops and conditions are useful. Flags. So about flag, like your awk has, like I will tell you about two flags which are important. So first one is hyphen small f, and another one is hyphen capital F. So first I will tell you what is hyphen capital F. So it will, like whatever you write after capital F, that will be your field separator basically. So we were writing inside your begin, right? Begin fs equal to hyphen. But if you don't want to do this much stuff, then what you can do is you can just write this and this. So yeah, this will basically set your field separator to hyphen. And now if I do print $1 from your fs.txt, then you can see that it just prints this. And if I don't write this part, then it will print whole line. So yeah, your hyphen capital F is used for specifying your field separator there. And what about small f? So small f is used when you want to use a predefined uh, awk script. So first I will tell you what is awk script, and then we'll see what is small hyphen f. So awk script is basically your awk command only, but written inside a file. So here you can see that I have this file evg.awk here. So that's your awk script. So whatever you are writing inside the single comma, you will write it here. Okay. So this is your begin block, and I have written some stuff here. What I'm doing here is I'm uh, printing. First, I will print name and salary for each of the employees, and then I will print average of these 5 salaries at the end. Okay. So how I can do that? First, I will print $1, which is your name, and $3. So here you can see that print $1 and $3, and then I'm doing sum equal to sum plus $3. So $3 is nothing but your salary, and like sum is your variable. You can initialize this to 0, or you don't initialize it, up to you. It will be automatically initialized to 0. So sum equal to sum plus $3, and at the end what I'm doing is average salary is sum divided by NR. So I already told you that if you write NR in your end, then it will be standing for total number of records. So here we know that total number of records are 5. So whatever sum you got of your salary divided by 5, that will be your average salary, right? So we'll quickly execute this particular awk file. So how you can do that? Awk hyphen small f avj.awk, and then you'll write your file name. Well, that was hello.txt. Yeah, here you can see that name followed by salary, name followed by salary. That average salary is 46,600, which is average of these 5. All right. And why this thing is coming double equal to an arrow? Because I have specified output field separator as that. All right. If I want to specify ORS also, I can do that. Double lines. And if I run it again, you can see that there is extra line. So yeah, that's all about other tools, and that's all from my side. If you have any doubts till now, you can just ask by unmuting or put it in chat box. I know it was very boring kind of thing, but I tried my best to make it interesting.
Oh, Chirantan, it was extremely well taught. We had a lot
Okay,
of fun.
thank you very much.
Thank you, Chirantan.
Okay, yeah, cool.
So I hope awk isn't awkward anymore. Next, we'll start with the next topic, which is said. Aditya Prakash, my friend from Muscat, will be taking over now. Aditya, can you hear me?
Hello.
Yeah, Aditya.
Hey, yeah, hello, Rahul. Yeah,
Cool. You ready to take over?
I'm just sharing my screen.
Cool.
Just tell me when it's visible.
Yes, we can see your screen.
Okay, so the slide is also visible.
Yes.
Okay, so good evening, everyone. Today we are, or I'm here to tell you about the SED command, and with no further ado, let's just jump in. So first, let me show you what man SED is. So if I just do clear, and the terminal is visible, right, Khatak?
Yep.
Okay, MANSED. So that was the manual of, this is the manual of SED. And what Unix tells us is SED is a stream editor for filtering and transforming text. So these are the two terms that just a small clarification. So when filtering is taking what you want out of a whole bunch of data, and transforming is converting it from one form to the form that you want. And another thing is that this is done on an input stream that is like what the data that you are working on is not directly edited, but it's actually taken into a different buffer, or say another temporary area, space, location, whatever you want to call it, which is known as pattern space, where the operation that you have specified is done, and then the output is shown. So I'll make that clear when we are doing a practical, when we are actually doing the terminal thing. And just the note there is that when you are performing this, so SED is done on a file, but each it performs its actions line by line. So what I mean by that is, first let's start with the command. Okay. First I want to teach you about the substitute command. So substitute is nothing but replace. Okay. So if I just quit out of here and let me just show you the file that we're working on. So file.txt. So this is the file that we're working on. It has many spelling mistakes. It has branch repeated twice, and there are some lines that should not be here. Okay. So the first thing I want to do is I want to change the branch. I want to change the AEM to AM because it's a simple spelling error. So what I'll do, I'll say SED, single quotes, I'll say S for substitute.
Kenapa
Then,
Aditya?
hello? Yeah. Okay, I'll say S for substitute. And then here is the old pattern. That means the pattern that I'm searching for, the string pattern, which is AEM. And then the pattern that I want it to be replaced with, AM and slash. And this is the expression slash command that I'm telling SCD. And now I have to mention which file should it work on. File.txt. Now if I press enter, as you can see, the AEM here is replaced with AM here. Okay, so that's the simplest command, the substitute command. But let me show you. But now, if I want to change branch, right? So what I want to do is I want to tell I am Aditya and branch EC and ITW. So I don't want to change the first branch, but I want to change the second branch. So what I will do is I'll type the old pattern BRNCH branch and then the pattern ECE, and then here I'll put a number 2, not, yeah, 2. So what this number signifies is that it substitutes the assuming this number is n. If we go back here, sorry, if we here this number is n. Okay, so then it substitutes the nth occurrence of your old pattern with the new pattern. So what I mean by that is, if you can read the first line, you see that the SED skipped the first branch and it only changed the second branch. It replaced the second branch into ECE, right? That's because this was the second occurrence of my old pattern, which is branch. Yeah. So that's the thing. But now let's know. I want you to gather your attention to one other thing, which is, if you compare, it was AM here, but it converted back to AEM. That's because all this is happening on another temporary area, and it's not happening in the file. If I just cat the file again, then you see that the branch is not changed, the AEM is not changed. So let's see how we can get past it. Okay. So what I will do is I will just do a cat file just for our reference, and then we'll use this. But now I'm going to use the -I flag. Okay. So by using the -I flag, -I stands for insert, which means I want SED to insert the changes into my file. If you guys are familiar with Vim, so then Vim is a stream based or any other stream based editor. Even in that, I is an insert mode, and only after you press I or say append, there are others, but when you press I, you enter insert mode, and then you can start editing your document or your text. So similarly, there is some correspondence there, here and there. So anyway, so if I do this and now press enter, okay, I didn't get an output. But if I do cat file.txt, as you guys can see, my actual file has been changed with the with the substitution that I wanted to make. Let's do the same for am, because nobody likes incorrect document. So aem and am here, and yep, that. And if I do cat again, okay, fine. Now another thing that's annoying me in this file is that my spelling is wrong. So I am supposed to be spelled Aaditya, but here it has an atrocious spelling of my name. So what I want to do is I would do -i, because I want the change to be stored. But if I do just Aditya and then I do Aaditya and just leave it and just go to cat file.txt, then yeah. So as you can see, it did change the name, but that only happens because when it's the first word. So when it's the first word, as you can see, there is in the bottom three lines there is this. So if I, just for example, I want to replace this with that, okay, and I do this. Sorry guys, yeah, sorry about that. So what I wanted to tell you guys was about the global flag, which is s slash let's say, yes. So uh, before that, what I'll do, I'll show you the append flag and then I'll show you the global flag again. So what I will do is I'll open the file in Vim, okay, and then I would just insert mode, come down, and should not have been here, and let's say I add another this here, okay. Then what would happen is, if I, okay, now cat file, okay, let me just clear everything, let me just cat file this, okay. As you see, so now if I run, I don't want -i, I don't want the changes, but I'm just showing you. If I put this and then I put, sorry, if I put that, I can spell it right, okay. So if I do this, then as you can see, only the first occurrence of this changed, because here we have two this in line 3 we have two this, but only one has changed and the second has not. So to make sure that we have all the old patterns changed into the new patterns, we use something called the global flag. And if I press enter, then you can see that all the this has been changed to that of that line. So anyways, that's the thing. And now suppose you want you want it to duplicate or reprint whatever addition, whatever edit it has done, then we use something called the p flag. Okay, we use something called a p flag. Let me do that on, okay, let me do that 1 minute. So if I do this, I do this thing and press enter, as you can see, every line that it changed, there's no if we compare, if we search for the old pattern in these lines, there's no this in the first or the second line, so it didn't do anything with it. But whichever line it changed, it did duplicate it. Okay, so that is the print command. But suppose I wanted to print only the lines it changed and not the lines it did not. So then I use the -n flag, which stands for the stands for the no auto output flag, or no auto output. So if I do this, then it will only show me the lines that it changed, and that too only once, because these are the duplicates that it's showing. So yeah, so until now we have shown you the substitute, the print, the global, and the two flags. One is the -i flag, which is to insert, and the -n flag, which is to not show the automatic output. So this is the print one, and now I also told you about the nth occurrence. Okay, and now let's go to the append. Appending is as simple as what it says. Okay, cat file just for our reference. Okay, so say after my second line, I want it to say that Aditya means sun. So I do sed. Okay, I will say 2. So this can be any number, and so this number says after which, at the end of which line should it append anything. So if I do 2a for append, and say Aditya means sun, and do file.txt. So as you can see, after the second line, it added a sentence, which means, or it appended a new line, which says Aditya means sun. So this is the append flag. And finally, we have just two more. Okay, so we have just two more. One is the delete and another is the expression. So let me just show you the delete one. So delete one, it's it's very simple, right? So let me just clear cat file.txt. Okay, so say I want to delete the line, I only want to delete the third line. Okay, so I'll do sed 3d and then do file.txt. As you can see, it deleted only the third line. Now I can do some other form of delete. I want to say I want it to delete not just third, but a range of lines. So what I would do is I would do say 1, 3, which means I want it to delete lines ranging from 1 to 3. So it will delete line 1, 2, 3. So as you can see, it deleted the first 3 lines and showed us the last 2. And also, if you want to delete the last line and you don't know its number, then you can just use the dollar symbol. Dollar stands for the last line. If I do $delete, it will delete the last line, right? It deletes the last line. And you can use dollar in the range. Suppose I want to delete the entire text file, I just do 1, $delete, and it will delete the entire text file. Since it deleted the entire text file, there's no output. That's and one last thing about the delete thing, you can also delete using pattern matching. So how that is done is, let me just cat file for reference. Okay, I want it to delete the line which has the word common in it. So I will do sed. I'll say /common slash p, and then I do file.txt. So as you can see, it deleted the line that has common in it. One thing we should all know is that these patterns are case sensitive. Suppose if I had done this, then it should not delete. See, it did not delete anything because it goes for exact pattern matching, right? So yeah, so that's why, since this common and this common are not the same, it did not delete that. And that is those are the kinds of deletions you can do. You can delete a particular line by doing sed the line number and then delete, or you can do a range of lines saying I comma j where it's starting and ending d, or you can do some pattern as shown here. Okay, now all this is like basic text edition, but now suppose if we not want now suppose if we don't want this and we want some, because patterns are generally something that can be generated, right? So patterns are a pattern. Okay, they follow a regular rule set. So suppose if we want to do that, then what I'm saying is that, okay, I'll show you an example first. So this is a file. Okay, and in this file, what I want to do is I want to take this second line and I want to flip it. I want to reverse it, but only the second line. So what I will do is I will tell SED and then first okay, I'll S because I want to substitute. Basically, I'll substitute and then I'll type out the command and then I'll explain each part of the command as it goes. A to Z, A to Z, 4, A to Z, and then 0 to 9, and then 4, and then and then 0 to 9, and then A to Z, and then 4 again, and then A to Z, and then 4 again. And now I'll do slash and backslash 4, backslash 3, backslash 2, backslash 1. And then global because I wanted to do perform this thing for every line. So now what I'm saying is, hey, CD, okay, fine. Before I forget, let's also add the file here, okay, expert.txt, okay. So now what I'm saying is I'm asking, hey, stream editor, I want you to substitute a pattern that contains ASCII values from small a to small z, and it's in group of 4. Okay. So that means the delimiter here is space, of course. So what I'm saying is a group of 4 ASCII values that can be any ASCII character in range small a to small z, the second of which is a group of 4 in the range 0 through 9, third of which small a to small z, and then what I'm doing, I'm the same thing goes for this, a group of 4 ranging, I mean, in the range small a to small z. And then what I'm asking it to do is take the fourth of this and print it first, take the third of it, print it second, take the second, print it third, and take the first, print it fourth. And I just told you what the G flag and the S flag are. So if I press enter, oh god. Right. Now it didn't work because this is an expression. And to run an expression, I need to run the expression flag. So this, because this is not your regular string, right? Oh, sorry. This is not your regular string. This is an expression where I'm saying a through a group of 4 of this ASCII range. So that's why I need to run the expression flag. Now if I press enter, then as you can see, if you compare the first one and the second one, it flipped the second line and it didn't do anything with the others. Suppose if I had done not 0 through 9 and if I had done A to Z here and had done the global, then it should flip every other all the lines except the second one because that's how the pattern matches. And if you see, that's what it did. Now, one last thing is that since it's ASCII, what we can do is we can be very general, very liberal with our range and say this ranges from 0, which is the 49th ASCII character, to Z, which is the 122nd ASCII character. So if I do this, sorry, 0, 1 is 49th, my bad, 0 is 48th. Okay. So if I do this, that means I'm saying that the first is a group of 4 ASCII values whose ASCII value is anything from 48 to 122. And this should still work because these small letters do fall between that range. As you can see, it did the exact same thing even though I increased the range. So yeah, this range, you can play around what this range is and all. It could be capital A to capital Z, it could be any ASCII to any other ASCII value. But yeah, so that's pretty much it about the about the SED command again. If I just recap through what we taught, what I taught, okay. So again, SED is a stream editor for filtering and transforming text. It takes input line by line to change, and then we have a few commands like we have substitute, and then we have substitute, okay, where it's just like replace, and then we have print where it duplicates or prints the line on which reprints the line rather on which it did the work, okay. Then we have append, which is just basically adding something to the end of a line. And then we have delete, which is delete, no need for further clarification. And then we have expressions where since we type a script here, and then we need to just remember the flag -c should be there, because otherwise SED search for regular strings, but here actually it's an expression. That is why we need the -e. Okay. And this thing that I typed here, this actually comes under regex, which is regular expression. Chirantan also mentioned about this, and as he rightly said, it's a huge topic on its own. But I suggest you do learn about it because it's very interesting. And yeah, and that's it. And finally, this is the documentation where you can learn about all the other commands, because of course I just touched the surface of stream editor. There are other commands where you can add a blank space, you can delete an entire line on its own, and then you can do a lot of cool stuff with it. In case you're interested, I'll just paste this link in the chat box. I think that'll be fine. Wow, not this. Just paste this link in the chat box, and then we'll see. Okay. So, yep, thank you for listening, guys. And if there's any doubt, please go ahead.
Thanks a lot, Aditya. A lot said.
Thanks, Carter. Thank you.
Thank you. So all of us will take a break for a minute or two, and we'll then begin with the next session, which is of assembly language. Thank you. Meanwhile, you can post your doubts if you have any while you're trying out any of the commands in the chat box or on the WhatsApp group. Okay, guys, so let's start with the last session for today. Aditya, you're still sharing the screen. So, yeah, cool. Thank you. So let's start with the last session for today, which is assembly language. It will be taken by Gyaneshwar. Gyaneshwar, are you here?
Yeah, yeah. I am clear, right? My voice is clear, right?
Yes, your voice is very clear. You can take it up.
Okay.
Yes, Ganesh. Well, now we can see your screen. We can't hear you if you're talking.
Yeah, actually, I wasn't
Yeah.
talking. Now it's audible, right?
Yes, audible.
Yeah. Okay. Uh, uh, okay. So the text is clear, or should I zoom?
All is clear, but any of the participants, if you feel the font should be increased or something, please put it in the chat box. Yeah, it's clear. Ganesh.
Okay. So today's session we are going to discuss about assembly language, and while reverse engineering, we like it might be any tool like Ghidra or x64 debugger. So we need to to put some breakpoints or uh, to do some jump statements. We need to have an idea of assembly language, as assembly language is a low level symbolic, like it is a low level programming language, and that is how machine actually understands the program. So let us start with this. So basically, uh, before starting with the syntax of assembly language, like whenever we start talking about programming language, the first things which we actually see are the syntax and then the conditional statements. Then we go towards loops and object oriented programming. But regarding assembly language, there is nothing like functions or loops, but there are some statements which we can actually use, like move, jump. So using this, we can actually create some kind of emulation, which actually seems to act like a function or loop. So uh, the syntax actually changes based on the architecture of the processor. Like there are different architectures, as far as you know, like there are Windows 32-bit and 64-bit. So like there are two different syntaxes which we can discuss today. uh, and I guess you can see my terminal.
Yes, Ganesh.
Yeah. So as Python files are abbreviated with .py and C++ files are abbreviated with .cpp. So assembly language files are abbreviated with .asm. Uh, and this is the sample code of an assembly. This is a sample code. Uh, so basically, what this particular file is doing is like, let me explain about the segments of this file. The first line actually, it actually declares, uh, like as many of the people might be knowing that C++ doesn't exist without assembly language, but assembly language can exist without C++. This kind of global declaration we can actually use for creating header files and use them in like low level languages like C or C++. Uh, and like you could see this highlighted thing label like this is how you can actually declare a region, like this is a separate region in the assembly file, using which we can this acts as a function, and this is like main function. So before knowing about these weird things like MOV, EBX, so let us move forward with the presentation. So basically, I have mentioned previously, like every CPU, there are different kind of CPUs, and syntax of assembly changes on different kind of CPU architecture. That is because of the registry coding. Uh, like let us see about 32-bit registers. This is how like these are the codes for 32-bit registers. Like you could see here, I was using EBX, ECX, all these. Okay, so all these we actually use these particular things to perform these particular actions. And similarly, for 64-bit registers, we have this particular coding. The difference between 64-bit registers coding and 32-bit registers coding is like everything would be same. I mean, the second decimal and the second digit and the third digit, but the first digit would be changed from E to R. Like you could see this, and this is what I have used here, and this is a brief intro about registers, and let us talk about assembly instruction sets. Uh, like uh, like we have some arithmetic operators or logical operators in C or any high-level programming language. We have these instruction sets which are move, which are used to data transfer from one register to another register, and control flows, and arithmetic logics. So there are several categories, not just three. There are several categories. Uh, so this is a basic introduction about the syntax of assembly language. Uh, so as I mentioned that assembly language is a low level language, so we can actually like when I list out the files in this, like you could see ex executable one, like C language, we even need like when we write the code for assembly language, we need to generate an object file which is like represented with .o, and then we'll use a linker command called LD, which is actually a linker, uh, which actually generates an binaries or executable from the object file which we generated. So basically, how we'll be doing that is, so there is a command called nasm. So so in this command we use this -f tag to generate the architecture of the output which we are actually generating. So here we are actually using 64-bit. I'm actually using 64-bit PC, so I'm actually mentioning 64-bit architecture. If you are using 32-bit PC, then just change it to 32. Uh, then you give the file name and the output file name. Just this is except the flag part and the value which are giving to the flag. Everything seems to be like a command which is like can be related to GCC. So you just execute it. then you will be getting an object file. So now we need to use the linker to generate the executable. So this is also same, like we'll be mentioning this -m flag to specify the architecture of the CPU which we are actually using. Uh, as previously Aditya, like in the previous thing when Aditya was actually telling about said command, he actually mentioned about manual. So every command will be having several flags which can be used along with it, like nasam for nasam or for LD, -f or -m are not the only flags which are available. Like you can actually uh, okay, no manual entry. Yeah. So like there are many flags. Like as I have shown you, like to mention the format, I'll be using -f flag. You can just see the manual of the every command to get an idea about how you can actually use that particular command. Uh, and after I have generated the executable file, I can run it. Uh, so you may think that there is no output for this, but let me show you the code once again. Actually, I just created a space for some registers, and then I have just exited the complete like I just performed the system call. So you can actually see the changes. Echo. Yeah, like like using this, you can actually see what the change happened after the system call. Basically, if you might have not executed this command in your PC, then once try to execute this echo dollar symbol question mark before executing the uh, file which you have generated now. Uh, then you could actually get some output like 0. So after the execution of this file, output is changed. So we can see that this is working. Uh, and regarding assembly language, like as you know, like there are data structures for the programming language like C or Python, which you might have learned. Similarly, we have two data structures. The only two data structures in assembly language are stacks and heaps. Like you might be knowing about stacks and heaps in DSA, so I am not stressing about them. But you can actually check about those. Like mostly every programming implementation which you will be doing in assembly, you will be using stacks and heaps. So this is just a small intro about assembly language syntax. Like if you have any questions, like you can post it in the chat box. Uh, like I think I just went a bit fast, but I think I am clear. So since we have covered the basics of assembly, like let us see like how we can use assembly in reverse engineering. So before going to that part, let me show you one more thing. Like as I have mentioned that we can actually use assembly files in C++. If you are curious like how to use it, let us see this. I just wrote a small function called add44. So basically this is a function uh, which actually which is used to add integers. uh, so I have actually generated this header file. No, I have generated the output file first, and then I have generated the header file. And and like we can directly include the header file into our program of C or C++ using simply, and we can actually use that as a function. So this is how you can use assembly language in your high level programming languages. uh, so this is just a small intro about assembly. I think you are clear, so let us move into the reverse engineering part. Just take a 2 minutes break, guys. Like, I'll be shifting into Windows and I'll be coming back.
So just a minute, guys. Ganesha will be switching over to his Windows, and we'll soon be starting the reverse engineering part of the assembly language. If you have any doubts again, anything, you can use the chat box.
Also, challenges related to the sessions have been added in the CTF platform, and 4 more new challenges are added today, and few more will be coming up soon. So do try them and try to get on the leaderboard. And they are fun, and trust me, it will be exciting. And if any doubts, feel free to ask them in the WhatsApp group.
Hello, guys. Like, I think you are able to see my screen.
Yes, Ganesha, we can see you.
Okay, so I'll be starting with the reverse engineering part. So basically, in this particular session, we'll be using two tools, like x64 debugger, you can actually go to this link. I'll share it in the chat box. And make it easy. Uh, so you can actually use this. We'll be using these two tools. So let us start. So untitled one is the execute, the first program which we'll try to debug. Let us open x32 debugger. Okay, so whenever we open this x32 or x64 debugger, so like since this is an executable, this executable will be like a prompt will be opened, and we can actually see this. Like, let me explain what are these. Uh, so the second, leave out the first column. That is just how the command flow is going to be. That's what it says. The second column actually describes about the memory addresses. The third column is regarding the hexadecimal, the command in hexadecimal format, and the fourth column is like the command in human readable format. Like this is how we have actually coded our commands in assembly language. So so let us get started. So basically, these all addresses are related to the system, so we don't need this. Uh, like first of all, we need to find where this application has been allotted. So let us open this tool direct it easy. Uh, okay. Let me open the file in this. So basically, whenever the only like directed easy can be used for many purposes, but I won't tell each and everything right now. I am just using this tool to find out the entry point and base address, so that this particular memory address value is just the summation of entry point plus base address. Uh, so like you can actually press F10. Yeah, F9. You can actually press F9. When you press F9, like you go Okay. So you could see like if you add this both, you will be getting this particular value. So this is the entry point where we need to start working, and you can even see that this is the entry point. So basically, let me just give a small walkthrough about this tool. So uh, as you might have seen, like we can open a file from this. Remember one thing, we need to run this tool as an administrator, and you can actually use these steps like step over, step into. Like mostly we'll be using run, step over, step into, and when suppose if there is a memory address like this, if we double click uh, on the command, like you could see like it is highlighted with red color. So that means that we have actually set a breakpoint at that particular case. So let me directly go into uh, before setting up breakpoints, like let us start here. So we can actually step over each and every command and see what's actually happening. uh, oh no, let's keep us bit. Okay, this is the entry point. So I can actually go through each and every command and see. Like we just came down because there was a jump statement at, like you could have seen there was a red color arrow which came on the left hand side. So there was a jump statement. So we just came up. Uh, so let me tell you, I have actually like before going more deep into this file, like I have actually mentioned like we don't have any conditional statements. Like we have conditional statements, but we there is no uh, functions or while loops which are available in assembly natively. But during this conditional statements like jump, there are more advanced jump statements like JLE, like that is actually a condition based jump. So if that particular when that particular statement is executed, if it matches the condition, then it would be going again to the topmost point. And like if you see uh, F9, okay. Step over F8. So you can actually like see actually the blue line which you might have seen, there was a jump statement like conditional jump statement at that point, but that particular statement didn't match the condition, so jump wasn't performed. But now it matched the condition, so jump was performed. Again now it didn't perform. uh, so you can go this way till you meet a deadline. Like you can actually see like this prompt. We are just going through that loop because Oh no, just went fast. Uh, okay, so this one. So basically, let me run this file directly, like run this executable. What happened? Okay, this also directly. So, like when I executed this particular executable, I just got a sentence called "try harder." Uh, like using this debugger, we can actually try to find like at this particular memory address, we can actually see that it is actually displaying that "try harder." So we need to bypass this. So if you can see at this point, like this is actually like whenever you reach this, there is a jump statement which has been executed. So you will go to this memory address and you will directly like system call happens and your like this particular program is terminated. So we need to set up a breakpoint here. Uh, and change the zero flag value so that this command doesn't get executed. Uh, so if you try to run now, uh, uh, this loop is little bit big, so it is taking a time. So that loop is just completed. So we just need to go down. Oh my god. Like you can actually see here, like this is the actual flag which need to be printed. Uh, but at this particular point, uh, this jump statement is no. at this particular point jump statement is executed and we'll get the try harder message. So instead of that, if we actually get this particular loop jump statement executed, then we'll actually go to the system call will be called, and this particular flag or the string will be printed. So this is how general CTF challenges would be. So what we should actually be doing is like we shouldn't set jump statement here. We should be putting a jump statement here and changing the ZF value so that try harder message is not printed and the flag will be printed. So this is how you will be uh, debugging these assembly language files. Uh, so this is just a one example, and we have uploaded another challenge in the CTF, like similar challenge to this in the CTF platform. So you can actually try solving that to get some better hold. Thank you.
Thank you so much, Gyaneshwar. So that will be the end of day 2. Any closing remarks, Dikshita?
No, that's all. Yeah.
Okay. Thank you so much.
Thank you, guys. See you tuned. See you tomorrow again for the final session of this workshop. Until then, enjoy the challenges. They are up on the platform and try them, and you can tell any doubts if any. Thank you.
Thank you so much, everybody. Closing this session. Bye bye. Have a good day.